Okay, now we look at another problem. Now in the next problem, we're going to be actually calculating the radius of curvature based on dy dx, that big giant equation that I showed you before. So we're going to make use of, if you know the slope, right, in terms of mathematical equation, y in terms of x, you can use that to calculate the radius of curvature of the slope at a particular point, and using that to calculate your acceleration. Okay, so in this example, the toboggan, okay, this is like a sled, is traveling down a curve, right? It's traveling down a curve which is approximated, right? Which can be approximated by a parabola, right? Parabola. So okay, so the equation of parabola is y is equal to 0.01x to the power 2. Okay? So determine the acceleration of the toboggan, right? A, the acceleration of toboggan when it reaches point A. I'm going to show you the picture in a little bit. When it reaches point A, where the velocity at point A is equal to 10 meters per second and is increasing at ATA equals to 3 meters per second squared. Right? So this is tangential acceleration. Right? So let me just give you that approximation. Right? So this is that slope. So the toboggan is coming down here. Right? So this is you sitting here with your girlfriend on a toboggan. Right? So you're going down the slope, and there's a, I don't know, there's a snowman here, I think. Okay, so this is all snow, right? And for those of you who have ride this before. So at this point, you are, so this is y, this is x. So this is 60 meters away from the origin of this axis. And this is point A, of course. This is point A. And the height here is 36 meters. Okay? So this equation is y equals to 0.01x squared. Alright? Give you a little bit of time to draw this. So next, how do we calculate the acceleration of this toboggan? Apparently, it has a constant tangential acceleration. ATA equals to 3 meters per second squared. Right? So that's great. At least we don't have to calculate this. The question is next, what is A and A? Right? Because we do need A and ATA to calculate the total acceleration at point A. Right? So the task really is to calculate what is A and A. And we know that in order to calculate A and A, we need to know first the velocity at A, which I think we do. Right? We give it this velocity. Next, we do need to know the radius of curvature at point A, right, for this curve. And that is the calculation, right, because we are not given the radius of curvature, right? Typically, that center is probably around here, and this is your radius of curvature of point A. And so you do need to calculate this radius of curvature based on the equation given here. Okay? Okay, so radius of curvature at point A. Right? We have that equation, the giant equation that I showed you before. This is 1 plus Vy dx to the power of 2, and the whole thing to the power of 1.5, or 3 over 2, divided by d square y dx squared absolute, right? So when you see these two bars, it means absolute number. It's always positive. So what is dy dx? So first of all, dy dx, if you do that differentiation correct, the derivatives, you get 0.02 x, right? And x happens to be at 60 meters. So you would put 60, x equals to 60, and that gives you a number which is, well, we can actually calculate this, 102 times 60, right? So that's equal to, this go away, so this is 1.2. Okay, so it's 1.2. So where you have 1.2 over there, right? It is a dimensionless number here, it's dy dx. D square y dx squared would be 0.02, right? Okay, so now you have these two numbers which you can substitute into this equation. What you have here is 1 plus 102, so that's 1.2. 1.2 squared to the power of 3 over 2 divided by 0.02. Okay, the denominator. What you get here is 190.57 meters. Okay. So therefore, your A and A is equals to your VA squared divided by rho A. So VA, as you remember, was 10, right? So this is 10 squared divided by 190.57, and that gives you 0.5247 meter per second square. Okay, and as you remember, ATA was 3, right? ATA was 3 meter per second square. So what you see here is that this is much larger than this number. It's about 6 times, right? 6 times larger. So you would probably expect your total acceleration to be closer to 3, right? 3 point something. So total acceleration at A is equal to 3 squared plus 0.5247 square root, right? So that gives you 3.05 meter per second square. Okay?